In this instructional video, we will go over characteristics of quadratic functions. The essential question is, how are some characteristics connected to one another? So let's begin with this question. What is a quadratic function? A quadratic function is a polynomial that has the highest degree of 2. Now, the graph of a quadratic function is a curve that is called a parabola. And this is how the picture looks like. This is a quadratic function. Now, how do we write an equation of a quadratic function? One way to write it is in vertex form. And it looks like f of x equals a times x minus h squared plus k. For example, y equals 2 times x minus 3 squared plus 4 is a quadratic function written in vertex form. But sometimes this form doesn't help. So we change it to a different form, which is called standard form. And it looks like f of x equals ax squared plus bx plus c. For example, we have this equation written in vertex form. I am going to change it to standard form. And we've done this before, right? So in order to change the vertex form of a quadratic to standard form, we need to begin by looking at what's inside of my parentheses and the exponent. So we have x minus 3 squared, the 2 out here and the plus 4. We are going to take care of them later. So remember, x minus 3 squared is the same as x minus 3 times x minus 3. So you've seen different methods on how to multiply, but I'll show you how to do it using the box method. So we have a 2 term by 2 term. So I am going to draw a 2 by 2 box. And I'm going to write x minus 3 at the top and then x minus 3 on the side. And now I'm going to multiply. X times x gives us x squared. X times negative 3, negative 3x. Negative 3 times x, negative 3x. And negative 3 times negative 3 is positive 9. So I'll draw my bow tie here because this is just going to remind us that these are like terms and we're going to combine them. So I am going to take my polynomial out. So I am going to write out x squared and then minus 3x plus negative 3x gives us negative 6x and then plus 9. Okay? All right, so this is what we get after we multiply. Now I am going to bring the 2 down that we had at the beginning, right? And then the plus 4. Okay? This x squared plus 6x plus 9 is equivalent to x minus 3 squared. Okay, so look. Now I am going to take the 2 and we're going to distribute it to every single term inside of the parentheses. So now we get 2x squared. And then 2 times negative 6 is negative 12x. 2 times positive 9 gives us 18. And now we add 4 to it. Okay, I just brought down the 4 that I had on the outside. Let me change its color. Down here, okay? So now the last thing we gotta do is to combine like terms. So we get y equals 2x squared minus 12x plus 22. This right here is the standard form of my quadratic function. Okay, let's move on. Now, what are the parts of a quadratic function? Let's begin with the vertex, okay? The vertex is the maximum, highest, or minimum, lowest point of the parabola. Now, you are also going to see vertex as the point hk. I mean, the vertex is a point on the parabola, okay? Now, hk comes from the vertex form. F of x equals a times x minus h squared plus k. But we're going to look at this second point more next time. So now, we are going to identify the vertex from a graph, okay? So we're going to begin with a minimum, okay? So, remember, minimum is the lowest point on our parabola, okay? Now, whenever we are looking at an equation, either in standard form or vertex form, we are going to have a minimum when a, which is the number in front of x squared, or in this case, in front of this parentheses, we're going to get a minimum when a is positive. So let's go ahead and identify the minimum. So if you look at this parabola, the lowest point is right here. This is the vertex. And we write the vertex as an order point, which is the point 0, 0 in this case. Now, if you look at this second graph, our vertex is the lowest point of our parabola. That's the vertex. And we write it as an ordered pair, which is -1, -4. Now, continuing on with vertex, okay, we're going to look at the maximum. So, minimum was the lowest point. Maximum is going to be the highest point. Now, if we are looking at an equation, we have a maximum when the a value is negative, okay? Now, let's take a look at both of our pictures, both of our graphs. We're going to find the maximum. So, if you look at your parabola, the highest point of the parabola is found over here. So, this represents the vertex. And once again, we write it as an ordered pair, which in this case is 0, 0. Now, don't forget, H and K. I just want you to be relating the order pair with the vertex form, okay, of an equation, of a quadratic function. So, let's take a look at our second graph. The highest point, once again, is here at the top of the hill. So this is my vertex, and we write it as an ordered pair. So the ordered pair here is 2, 1. And again, H and K, okay? Pretty easy, right? Let's move on to the next part. Now, please move on to the next page. Number 2. Again, we're looking at the question, what are the parts of a quadratic function? So, we're going to look at the second part, which is axis of symmetry. The axis of symmetry is the imaginary vertical line that cuts the parabola in half. Okay? So, let's go ahead and just take a look at one example. Okay? So, we have our parabola. Okay? We need to look for where we can cut the parabola in half. Okay? Again, this is a vertical line. So I'm going to show you. If I draw a line on this specific place, you will notice how we cut the parabola in half. Now, I want you to look at the parabola. This line, called the axis of symmetry, goes through the vertex. Now, we write this line as an equation. The axis of symmetry is x equals -1. Why? Because if you notice, the vertical line goes through the x-intercept of -1. Okay? So again, and going back to what you've learned about special lines, anytime you have a vertical line, the equation will be x equals. So, the axis of symmetry is x equals -1, and please notice that it goes through the vertex. Okay? Now, if you notice, the vertex is -1, -4. How can we connect the vertex with the axis of symmetry? Well, the equation of the axis of symmetry is the x value of the vertex. Isn't that cool? All right, let's move on to the next example. So now if we take a look at this parabola, we can draw a vertical line that cuts the parabola in half right here. Okay, we need to make sure that it goes through the vertex. Okay. And now we can come up with the equation. Okay. So if you notice, this vertical line goes through x equals 2, right? So the axis of symmetry is x equals 2. And just to verify, the vertex is 2, 1. So the x value of my vertex matches the x value of my vertex. Okay, the axis of symmetry matches the x value of the vertex. Okay, so now, keep on filling in your notes. So, if you know that the vertex is hk, then x equals h. That's what we were just talking about. Okay? Now, if you don't want a graph to find the axis of symmetry, or the axis of symmetry is not a whole number, and they give you an equation, then you can use the formula x equals -b over 2a to find the axis of symmetry. Okay? But we're going to do that next time. We're going to move on to the following part, which is the x-intercepts. The x-intercept is where the parabola crosses the x-axis. X-intercepts are points where the parabola crosses the x-axis. Other names for the x-intercept is roots, zeros, and solutions. So since we have a curve, a parabola can cross the x-axis twice, once, or none. So let's take a look at the first example, okay? This is an example where we have two x-intercepts, okay? Now remember how we have other numbers for x-intercepts? Anytime we have two x-intercepts, that means that we're going to have two solutions. Okay? Now, whenever we write x-intercepts, we write them as ordered pairs. Okay? So let's take a look at the graph. So the graph crosses the x-axis where x is -3. So we write it as -3, 0. And then it also crosses the x-axis when it's 1. Okay? So then that will be 1, 0. That is my second x-intercepts. Again, I have two x-intercepts because we have a curve. It goes down and then it comes back up. Or it goes up and then comes back down. Right? Okay, now, something that we're going to learn is factors. Okay? So, factors are binomials that we multiply each other and help us create an equation. So, we can build our factors from the x-intercepts. Okay? This is how we write them. We write two set of parentheses since we have two x-intercepts, and we put an x in them. Then we're going to take our x values and we're going to do the opposite. If it was a -3, it'll be a +3. So if it's a +1, it's going to be a -1. Okay? Please know that all of these are connected to each other. Okay? All right, so again, this was an example where we had two x-intercepts, two solutions. Now, the parabola can also just touch the x-axis once, so that means that we have one x-intercept. So when we have one x-intercept, we have one solution. Okay? So let's go ahead and find the x-intercepts, or the x-intercept. And it's at this point, 3, 0. So that is my x-intercept. Okay? So then if we write it as a factor, this is how it would look like. We're going to do one set of parentheses, and then I'm going to do the opposite of what I have up here, minus 3. Now remember, these are quadratic functions, so we need a degree of 2. Okay, so anytime you just have one x-intercept, this is how you're going to write the factors. Okay? Let's move on to the last one. This is an example of when we have no x-intercepts. Okay? So right here we have no x-intercepts. All right? So that means that we have no solutions. So we cannot have any order pairs, right? Because it doesn't cross the x-axis, so that means that we cannot have any factors. Okay? We're almost done, guys. Let's move on to the last section where we're going to do y-intercepts and domain and range. Okay? This is 5 and 6 on your notes. So the y-intercept is where the parabola crosses the y-axis, and you will always have only one y-intercept, and the y-intercept is the c value in ax squared plus bx plus c. Okay? Now, quick review for domain. Domain is the list of all of the x values. So we look at the graph from left to right. And then the range is the list of all y values. And we look at the graph from bottom to top. So we're going to have two examples where we're going to find the x-intercept and the domain and the range. I'm sorry, the y-intercept. So if you look at this parabola, the parabola crosses the y-axis right there. So this is the y-intercept. And we write it as an order pair. 0, -3. So that is my y-intercept. Now, let's take a look at the domain. From left to right, we have two arrows. So that means that my parabola keeps on going from left to right. So that means that my domain is all real numbers. Okay? Then my range, we gotta look from bottom to top. So if you notice, we have a lowest point over here, and then my parabola goes up. Okay? So I'm gonna start by writing y. My lowest y value is -4, and it goes towards positive infinity, right? So that means that y is greater than or equal to -4 because we have a curve down here. It's included, okay? The last example is as follows, okay? So the y-intercept is where our line crosses the y-axis, which is here. The y-intercept, which is 0, 5. Now my domain, from left to right, it just goes to infinity, so it's all real numbers. It goes to -infinity and positive infinity. And then my range, see, let's see, this is the lowest point, and then it goes up, right? So then that means that y is greater than or equal to 2. And we are finished. So now I want you to try this section right here. You need to identify all of the characteristics when the graph and the equation is given. Okay? Once you are done, please write your summary for this video notes. Have a good day.